Yeah, I just brought a bunch of these D1-Mini Wi-Fi modules. Yeah, these are based around the ESP8226EX Wi-Fi chip. Basically, it's a Wi-Fi chip integrated into a 32-bit microcontroller. What makes this attractive is it's an all-in-one solution for like smart home gear, which can be programmed through the Arduino environment. All you need to do basically is just download and install the D1-Mini library, which is freely available, which makes programming very easy. Wow. What I'm hoping to do is to interface this to Alexa, so I can switch various items that I require around the home. What I'm looking to do, I'm looking to have it shielded on a PCB that contains a relay. That actually turned out to be the easy part. So after doing some digging, it turns out that interfacing to Alexa can be quite tricky and clunky if you don't understand Alexa skills. I'm more of a hardware man myself, so I did some more digging, and it turns out that interfacing a D1-Mini to Alexa can be quite simple. Well, it turns out that Alexa has support out of the box with the built-in WeMos smart switch devices you can buy. Basically, I think it was an update that was brought in. I can't remember the date. Basically, it's an update which allows Alexa to talk to WeMos, built-in WeMos enabled devices through UPnP, broadcasts over UDP. Basically, what that means is that effectively Alexas are always waiting and listening for a response to connect to a WeMos device. So for Alexa to discover D1-Mini, all I need to do basically is to get the D1 to effectively spoof Alexa into thinking that she's discovered a WeMos device. So after doing a bit more digging, I came across a piece of code which I hardly had to change. Effectively, I didn't really have to do much to it at all. I've added a few extra bits to it just so I've got like a manual override, which is effectively nothing to do with the actual main bulk of the code anyway. So I'll show you that later anyway. So what I've done, I've captured the schematic and the PCB. Because what I'm hoping to do is this is effectively going to be a shield that's just going to plug into a header on the PCB that contains a relay, which I'm hoping to. Well, I don't know. Several different items I want to switch. I want to switch my download lights, and I also want to switch socket as well for my wife's electric blanket. Anyway, I'll show the schematic. Let's have a look. So I've captured it all on Altium, and you'll probably notice as the schematic, it's non-uniform because all the devices I've created my own libraries. I find that it's easier creating your own than actually trying to look for their footprints and whatnot. So anyway, so yeah, so there it is. So effectively, it's very simple circuit. There's the WeMos, the D1-Mini. There's a button I've incorporated. So no big deal. Effectively, all it's doing is just activating an NPN transistor which activates this relay here. And I've got myself a little switch mode power supply. It's got this is one that I purchased. It's got quite a small footprint. I'll show you later anyway. And a 5-volt voltage regulator just to power the WeMos D1-Mini. Let's have a look at the board view. So zoom in. So this is the board view. It's such a simple circuit. It's just a 2-layer. It's just if I can actually grab it and move it. Yeah, it's just a 2-layer board. So this is a switch mode power supply, this is a relay, and this is the header where the D1-Mini is going to sit. It's a 5V reg and transistor, simple as that, diode protection for the relay. So I've been lazy this time. I've actually got this printed professionally by a company called JLC PCB, which is extremely reasonable cost. So I can get 10 of these printed out and it works out to £20. What can I say? If you're thinking of doing this yourself, I can't stress that when you're dealing with mains, you do need to know what you need to understand creepage and clearances and stuff like that. You need to understand what's the tracking index of the FR4 that you're using. That will all impact on your creepage. Not so much clearance obviously, but your creepage. So I've designed this so I've got 4mm clearance, which is good for a double insulation in a category 2 environment. That's an environment when you can expect transients at 2500 volts. Anyway, we'll talk about that later anyway. But yeah, I've had some, so I'll show the boards which come through today actually from JLC PCB. Now good, I'm very impressed with them, I'm happy. But there's one small problem that I'm not happy with, which I'll show you here. Let's just zoom in a bit. So there's your PCB. Yeah, it's just your standard FR4 1.6mm. But the only problem I did ask for a cutout in my Gerber files, but I didn't get it for some reason. I don't know why. I don't know whether or not it's a mistake I made on Altim. I don't know, but I've not got the cutout, which worried me in a way because I was sort of on the edge with my creepage. But as it turns out, I have had these tested with a compliance tester, which I'm lucky enough to have access to, and it's absolutely fine. But it's just a small annoyance from JLC. But other than that, I'm quite happy with them. There's just a bunch of them here. And it cost me, I think it cost me about £25 including delivery, which I can't moan at that. So there you have it. So I think what we'll do now, we'll go to the soldering bench and we will solder our components on and take it from there. Right then, let's get it soldered. You'll probably notice that I've already soldered on the connector on here and the terminal connector and the fuse. That was because I needed to verify that I'd still got my isolation between the high voltage and the potentially low voltage here that I could be switching. Fortunately for me, I have got access to a compliance and analyse tester, and if you are going to attempt this job yourself and you are dealing with mains, you have to be very careful when it comes to creepage and clearance, especially when it comes to high and low voltages, because the last thing you want is any high voltages making their way into your low voltage line. So luckily for me, I managed to test it and verify that I have got the isolation there. I've got reinforced isolation, which is good. I've got some of the test results here if you're interested. I've got to tell you, because I'll show you. So what I wanted to verify is that I've got the isolation between these two, because that's going to be the mains live, that's going to be mains neutral, and these are the contacts of the relay. and I could be switching low voltage. You see, that's because I left it in this configuration, so I could say, you know, we've got 12 volts going in here, switching it, and switching whatever item you want to. So I just needed to verify that, and I don't know if you can see there with the test results. You know, I was doing withstand voltages up to 6 kV and it was passing, so that's pretty good, so I'm happy with that. And the same goes again between the contacts of the relay. I just wanted to verify that I had some decent isolation there. I know it's going to be switched at the same potential, but I just still wanted to verify it, and again, you know, it was passing up to 4 kV, so that's good. So yeah, if you are going to attempt this, you have to be very careful. You have to, you know, things you have to think about is what voltage category is the item going to be placed into. What's the tracking index of the FR4 that you're using? You know, just things like that you have to think about. Like for me, this is going to be in voltage category 2, so which means pluggable items basically, and I could expect transient over voltages up to 2500 volts. You know, that is not uncommon, you know. And if, for instance, say you want to go in category 4, that's basically at the mains, you know, in your consumer unit. You can expect voltage transients up to about 4 kV, so you know, these are the kind of things that you have to think about when you are designing and building things that are going to be connected to the mains in some way. Anyway, just thought I'd have a chat about that quick. So right, let's get on and do some soldering. Right. Right, so that's that soldered. Put the legs on. All I need to do now is just we'll walk through the programming of that shortly. I'll show you the program. Let's put these on. So I'm going to have these stood in a enclosure, glued to the bottom. I can't take full credit for the program that runs this, because this is a combination of a program which I got off the internet and a bit of tweaking that I've done to it, just so it works how I want it to. Yeah, which I'll throw in a link underneath the video, and you can have a look at it. It is actually a piece of code that is emulating the Belkin wireless socket, but we'll get into that in a moment. So as it is, this, I don't know if you noticed on the PCB there's an actual 5 volt supply coming from the regulator. I've actually soldered a leg on the anode of the cathode, sorry, of the of the input protection diode here, just so I can program it while it's in circuit. So anyway, let's go and get the computer and have a look at programming the device. So there it is in the enclosure. A little annoyance, the enclosure that I ordered, it was from Amazon, funny enough, apparently was supposed to have been 100mm by 60, I believe. But I know for a fact that my board is 85mm by 47, but it don't fit in, so I think there's been an error made somewhere. It is 100mm by 65, but when you look at it internally it's a lot less, so it doesn't quite fit, but I've managed to sort of angle it in, which is not a problem. You know, it's fine for what I'm using it for. I've got it actually connected, activating this socket here. I've got it on a bit of 0.5mm flex, because I was a bit I didn't have much space to play with. I tried 0.75, but it was a bit tight. But I've got this stuff, I've got it fused down to 3 amps, which is fine for what I need it for. Because this is only going to be switching my wife's electric blanket, and that draws, I think it worked out about 0.75 of an amp. It's you know, it's very low powered. So, you know, if you are going to do something similar, you've got to make sure that everything's fused correctly. My tracks coming from the relay, I calculated them out at 10 amps continuous, and I can manage 16 amps in short bursts. I wanted to get more out of it, but I just didn't have the space for the board that I was working for. So yeah, that's another thing to keep in mind when you're dealing with currents and that. You've got to make sure that your tracks are going to be able to carry the current that you're drawing, basically, as you could end up having a fire. And also this enclosure is a fireproof enclosure to VW0, which is good, because, you know, this is over 15 VA, and I always recommend fire enclosure for anything greater than 15 VA, because we could be switching a lot more than that, up to 3 amps, which works out more than 15 VA. So there you have it. So like I said earlier, I've left the programming process out of it. This is electronics blog, not a computer programming blog. But what I'll do, I'll leave a link to the code down the bottom. So all we need to do now is just screw this together, pair it up with Amazon, and see if it works. So I'll put this together and find my screwdriver and get this together. So I think all I need to do is just plug it in and ask Alexa to discover my device, and she should discover it. I've programmed this under simply blanket. I think the code that's that hopefully I'm going to link below, it just comes as the socket. You know, you can call it whatever you like. Especially if you're going to think of having multiple items around the house, you will need to change, obviously, the name of the item, and I believe you need to change a serial number too, else Amazon won't discover a new device. Anyway, so let's plug it in and see how she blows. Yes, it was quite an easy process, really. I didn't record me saying Alexa discover my device, so I didn't think I had to. Basically all I did was just plug it in, and ask Alexa to discover my device, and she discovered it. So there she is there. Alexa, how are you doing today?
I'm feeling pretty accomplished. I've been practicing my magic spells. You should try out some spells too. Just say, Alexa, Wingardium Leviosa.
Oh my god. She's a funny old woman, that Alexa. Anyway, let's see if we can't get her to turn on the blanket. Alexa, blanket on.
Okay.
There you go. Don't know if you can see the LED. Alexa, blanket off.
Okay.
Alexa, blanket on.
Okay.
Alexa, blanket off.
Okay.
Right, let's see if we can't get her to tell us a joke before we go. Alexa, tell me a joke.
Why is 4 o'clock in the morning like a pig's tail? Because it's twirly.
Alexa, you're a fool. She didn't like that. Alexa, Google Assist is better than you.
Sorry, I don't know that.
I bet you don't. Anyway, I hope you enjoyed it, and right, so my wife's going to be happy now. Oh yes, well, one other thing before I go, I need to show you. One other good thing about the excuse my camera skills, the Alexa app, is that it's on the cloud, which means you can switch it anywhere you like, you know, anywhere in the world. So they're all my devices. I've actually got, I actually did build another one, socket, but that's in my daughter's room and she ain't going to let me in there, so I don't know if you can see that. There's your blanket. Yeah, so effectively if I just click on the blanket, plugs off at the minute, there you go, it's on and off. So that's great. So you can actually switch this over the cloud, which means you can switch it anywhere you like. So you enjoyed that, and I'll catch you again later. Bye.